Hi guys, so today basically we'll be doing is chapter 5.3 properties of logarithms. And before I get to it, I'm just going to go over the properties of log functions that you should probably memorize and just know in general. So number one is basically log base of 1 is equal to 0, and as well as for number 2 is log base of b, which is like basically the base is the same number as the number beside it, is going to equal to 1. Number 3 is basically the product rule. So when basically it's log c of a and b, and it can just basically be written also as log plus a log. And for number 4, which is basically our quotient rule, is basically when a log is basically dividing, it can be expanded into two logs subtracting each other. And for number 5, which it basically says that the exponent can be moved in front of the log. And number 6 is basically the change of base. This question I'm going to go over is the expanding question, and this is our question over here. So basically the first step I'm going to do is that I know that the square root over here, so I want to remove that. So it's basically going to equal to log 2x minus 7 1 over 2 divided by 3. And looking at the properties of logarithmic functions, I already know that number 3 is fine, so I can leave it by 2x minus 7 in the brackets. And I'm going to look at number 4, which is basically the quotient rule. So the 3 should be subtracting. So it's going to equal to log 2x minus 7 1 over 2 minus log 3. And basically looking at the rule number 5, I know that the exponent, the 1 over 2, can be moved to the front of the log. So it should equal to 1 over 2 log 2x minus 7 minus log 3, and that should be the final answer over here. My question is going to be about condensing. Condensing is basically the opposite of expanding. You're going to be making it smaller. So the first step I'm going to be doing is I notice that there's a 3 in front of this log. So I'm going to be moving it all the way back over here. And as you can see by using number 5, rule number 5, the exponent's over here, I can move it to the front. And so it's basically going to equal to minus log x2 plus 5, and it's going to be 3 at the top over here. And it's going to be 3 log x plus log 6. So I'm also going to do the same thing over here. I'm going to transfer 3 to the x. So now I basically know that the next step I'm going to be using is I'm going to be using rule number 3. I know that the 6 as well as the x is going to be are adding together. So I'm basically going to keep them right next to each other using basically rule number 3. So we use rule number 5 first, and now we're using rule number 3. So it's going to equal to log 6 x3, because the 3 goes to the x over there, minus log x squared plus 5, and then 3 at the top. And basically the last step we're going to be using is going to be step number 4, which is the dividing. So I know that because it's subtracting, it's going to go under. And so basically it's going to equal to log 6x3 divided by x2 plus 5. And then it's going to be with 3 at the top. So basically this is going to be our answer over here, right over here. Right here is going to be answer. And so basically we used rule number 4 at the end. So these are the 3 rules that we ended up using: rule 5, 3, and 4. For example number 3, I'm going to be evaluating each log, and in this case I'm going to need a calculator in order to find out, and it's basically going to be like mostly a decimal number, and it's going to be rounded to like the 4th decimal point. So basically in this one I'm going to be using rule number 6 over here, where it's basically the change of base rule. So the base, which is x over here, and the a is going to be transferred over there. So basically meaning that log 590 is going to equal to, the b is going to go at the bottom over here, and the a is going to go at the top. So it has to be changed to 10, because in a calculator it's basically log 10 always. So it's going to be log 10 90 divided by log 10 by 5. And basically I'm going to divide that, and I get 1.954 divided by 0.6989. And then I'm basically going to divide this number, and I'm going to end off with 2.7958 as my ending number. And basically this number is going to give me, this is basically the answer. So this is when you evaluate log 590. The answer is 2.758. So basically step number 1, all you need to do is basically use rule number 6. And that's basically all you need to do in this case. Change it and then divide it and use it. Number 4 is going to basically be a question about simplifying. And I'm trying to simplify it to like the lowest I can. And basically first I'm going to start off by looking at this over here. I can see this negative 5 over here, and there's a 2. So basically what I'm going to do is just make negative 5 divided by 2. And it's going to be log 7x. So just to make it easier for me to end. So basically it's going to do the same thing, plus log 7x and log 7x squared. So basically at this point I'm going to be using rule number 5, where I'm going to be moving this exponent basically in front of the log to the back of it, and I'm going to be moving that. And so basically it's going to be log 7x squared plus log 7x subtract log 7x 5 over 2. So basically from this point on I'm going to be using rule 3, because 2 logs are adding, so I'm basically multiplying those 2 together. So it's going to be log 7x squared times x, and it's going to be subtract log base 7x 5 2. So basically this answer going to give me log 7x3, and as I'm subtracting, basically it's going to be known as division. And division, when 2 exponents are dividing, basically the exponent is subtracted. So it's basically just going to be x3 subtract 5 over 2, and this is going to give me log 7x 1 over 2 I'm going to move it back by using rule of 5. And its answer is going to be 1 over 2 log base 7 of x. And this is basically going to be a simplified form. And basically, if I want to plug in, I want to make sure that my 1 over 2, if I plug it in to these x's, it'll still be a positive number, so it'll still work. And my x is still going to be greater than 0, so that's good. Number 5, I'm going to do an exact value question. And basically what you do here is you're going to be finding a number which is not going to be like a decimal or anything like that. It's going to be an exact value. So basically, I'm going to look in the brackets first, and I know that I can notice that's log to the base of 3 of 81. And basically, I know that 3 can pretty much go into 81, so you can just basically just make yourself a factor tree. And so I know 9 times 9 is 81, and I know 3 times 3 is 9. And looking from this, I know that there's 4 3's, so basically it's 3 to the exponent of 4. So I can write down log 2 brackets log 3, and then 3 to the 4, 3 to the exponent of 4. And now I can cross the log as well as the 3 out, which is basically just using one of the methods over here. Now, if you look at number 2, which is equals to 1, but then times 4 is equal to 4. So it's going to be, we're going to end up with log base 2 of 4. And again, I'm going to make a factor tree again, and I know 2 2's go into there, which is basically just going to give me 2 to the power of 2. And now I can basically write log 2 base 2 exponent, and I can just cross this out again, leaving me with the 2 over here, and exact value is going to equal to 2. So mainly in these type of questions, exact value questions, you're basically using rule number 2 over 6 is going to be the last example, and basically you're going to be writing each log in terms of log 3 and log 5. So basically, I know I have log 125 divided by 3. And looking at my rules over here, I'm be using rule of 4 as well as rule of 3. And basically, it's just going to equal to log 125 subtract log 3. And looking at 125, I know that can possibly go into 5. And because we're looking at putting it in terms of log 5. So 125, we can just make a factor tree here. I know that goes into 5 times 25 is 125, and then let's go 5. So this is basically going to be 3 5's, which is 5 to the power of 3, is equal to 125. So it's going to be log 5 to the power of 3 minus log 3. And looking at rule number 5, I can move this exponent number 3 to the front, and it's going to be 3 log 5 subtract log 3. And this is just going to be my answer. It's in terms of both 3 log 3 over here and log 5, which is my answer. So it's going to be 3 log 5 subtract log. 3 properties of logarithms, and hopefully you learned a lot and you do good on the worksheet.